Welcome back, Honors Algebra 2 students. This is Mrs. Fallon. We are on page 295 of your student journals. We are talking about lesson 10.3, which is all about two-way tables, joint and marginal frequencies, and then something called conditional relative frequency. So we're going to talk a lot about kind of how to organize data into a table, and then talk about how we kind of use that data in a table to kind of help us make sense of it. So first of all, a frequency table or a two-way table. So a two-way table is often called a frequency table. So basically it means you're kind of gathering data and you're about like how often something occurs. And then you're putting it into a table kind of like you would like taking a survey or something. So it's a frequency table that displays data collected. And here's the catch. It has to be from one source that belong to two different categories. Okay, so some of the things that we're going to collect data on is going to be something like we're going to use something like we're going to do a frequency table based off of like 9th and 10th graders, and we're going to ask them you know, like if their attendance, if they're virtual or in person. And so when you're asking a 9th or 10th grader, right? So first you have to determine if they're a 9th or a 10th grader. So that's one, I guess, class or one data you're collecting, whether or not they're a 9th or 10th grader. And then the other data you're collecting is whether they're virtual or in person. But the source is still the same. You're still collecting like kind of two pieces of information from one person, I guess. So each person is kind of telling you two different answers. One, whether they're a freshman or a sophomore, and one, whether they're in person or virtual. So once we make a two-way table, and we're going to go through a few examples here, we're going to do something called a joint frequency. And so a joint frequency is each entry in the table. And so again, it's just kind of the data you're collecting. A marginal frequency. So again, these are kind of the difference here. A marginal frequency is the sum of the rows and columns. So if we wanted to ask all the 9th graders if they were virtual in person, the total number of 9th graders, for example, would be a marginal frequency, because it's like the sum of all of the 9th graders, whether they are virtual or in person. A joint relative frequency. So this is where we kind of get into kind of collecting some data. It's the ratio of a frequency that is not in the total row or in the total column to the total row. Let me say that again. The ratio of a frequency that is not in the total row or the total column to the total number of values. So what we're going to look at is for a joint relative frequency, and that's kind of a hard one to kind of put into words. For a joint relative frequency, we're going to look at kind of like a joint frequency, so like an entry in your two-way table compared to the total of the whole table. So I'm going to give you an example here. So we're just going to kind of draw my own little two-way table. I'm just going to draw kind of this extra piece here. Okay. All right. So what we're going to collect, and I was going to use the same example that I was talking about before. We're going to talk about attendance. And then we're going to talk about in-person versus virtual. So a lot of this is nice because some of those tables will be done for you, but it's kind of nice to see kind of a table kind of done completely. We're also going to talk about like what class. So whether you're a 9th or a 10th grader. So we'll do 9th. We'll do this one. So we'll do 9th, we'll do 10th, and we'll just do a total row down here. So every data we collect, so let's say we collected data, every entry put into this table is considered a joint frequency. So for example, if we said there were 193 people, that were ninth graders who were in person, and then 282 ninth graders were virtual. There are 475 total ninth graders. So we consider this a marginal frequency. So remember, I said it's the total of a column or a row. So the numbers in these individual spots are considered a joint frequency, whereas the sum would then be considered a marginal frequency. And then we had 203 in-person 10th graders and 415 in-person or virtual 10th graders for a total of 618. And then this total would be 396. This total would be 697 if we just added them together. And then whether you do a total this way, like across horizontally, or total vertically, you should still end up with the whole thing. So this brings me to what we were talking about here, the joint relative frequency. So it's the ratio of kind of a joint frequency over the total. So in this case, maybe it's just easier to kind of give an example. It would be like 193 over 1,093. So it's the number of in-person ninth graders compared to the total surveyed, right? The total number of people surveyed or the total surveyed. So that's what a joint relative frequency is. So just to kind of maybe, I don't know if we can add this in here. So each individual item right here, so like the 203, the 450, the 193, the 282, that's what we considered a joint frequency. Okay, so that's kind of what a two-way table looks like. It's gathering data. We're storing it in our lovely little table here, and then we can kind of do we can make some predictions based off of that. So a joint relative frequency, like I said, is, what percent of, might ask you something like, what percent of people surveyed were in person and in ninth grade? So you'd have to look at ninth grade in person compared to the whole. Or what percent of people were 10th graders who were virtual? So 415 out of 1,093. So that's what a joint relative frequency is. So it kind of compares to the whole thing. So it's, I guess a joint frequency over the total surveyed. That's probably the easiest way that I can kind of describe it rather than kind of write out the definition of sorts. Next, a marginal relative frequency is the sum of a joint relative frequencies in a row or a column. So for example, a marginal frequency, you would use a marginal relative frequency. You would use like one of these totals. So like, for example, if you want to know what percent of ninth graders were surveyed, you would take 475 out of 1,093. So again, just like a joint relative frequency, a marginal relative frequency is made up of a marginal frequency over the total surveyed. Remember, a marginal frequency could also be this. It could be, the number of people surveyed that were in person. So like what percent of people surveyed were in person in our lovely little two-way table. You could do 396 over 1,093. Or how many people were virtual? 697 out of 1,093. So again, a marginal frequency is any kind of the sum of any row or column. So then we get into conditional relative frequency. So a conditional relative frequency is comparing a joint frequency over a marginal frequency. So I'm just going to write down joint over marginal. So for example, we could have done like 193 over 475. Of the ninth graders surveyed, how many of them were in person? That might be a question you would ask for a conditional relative frequency. So we're only looking at ninth graders surveyed, so not out of the entire group surveyed, but only out of the ninth graders surveyed. So that's your marginal frequency. What percent of the people were in person? So you would compare this joint frequency to this marginal frequency. What percent of the 10th graders were in person? Again, you would do 203 out of 336. So again, a conditional relative frequency is kind of a combo between the two. You take a joint divided by a marginal, and that's what you get for a conditional relative frequency. Okay, so what we're going to do is we're going to actually, you can make a two-way table that contains just joint relative frequencies or marginal relative frequencies, or it can just conditional relative frequencies. So a two-way table could store data, like the raw data, like how many individual people answer this, or it could store
if you did a two-way table that stored like the joint relative frequencies, you would put in the percentage, or a lot of times they write it as decimal, into these columns. Like for example, if I want to do the joint relative frequencies, rather than write in 193 here, write in whatever 193 divided by 1093 is. So that decimal I would write here. And then for the virtual ninth graders, I would take 282 and divide it by 1093 and write that decimal or percent in here. A lot of times it's just a decimal. So that's doing a two-way table, and we'll do a couple examples with that, but that's doing a table with using frequency, marginal frequency. So we can do both. Let's do a couple different examples that are in our student journals first, and then I want to kind of go to our extra packet and do a few on there as well. So let me find our, so this would be page 296. So this is, again, just kind of the extra practice that's in your student journal. So this, what they're giving you here is kind of like they're asking you to complete a two-way table. So what's special about a two-way table is, again, it's a collection of data, right? So when you're completing this two-way table, you have to remember, again, anything going this way has to add up, and anything going this way has to add up. So if this number is 60, right, then in order for me to have a total of 130, this number had to be 70. So this is one way you can kind of just complete the table. This number over here would have to be 72. Because 72 and 58 add up to 130. This number here would have to be 50. Again, for this total of this marginal frequency to be 72, I would need this total to be, and 50 to be here. This could be 48 if you look across to get 70, and then of course this could be 10. So this is just one way to kind of fill in a table. And so again, kind of same deal for number 2. You could kind of be given different values in here. You might fill in 1 here. I would do 45 here, which would mean this would be 21, and this would be 50. Again, this sum vertically needs to add up to 75, and this sum horizontally needs to add up to 45, or 75, sorry. All right, number 3 says, a survey was taken of 100 families with 1 child and 86 families with 2 or more children to determine whether they were saving for college. Of those, 94 of the families with 1 child and 60 of the families with 2 or more children were saving for college. Organize these results in a two-way table and then find and interpret the marginal frequencies. All right, so again, kind of the same deal. We're going to draw a two-way table. So I'm going to show you how to do this. All right, so I'm just going to draw. Normally a two-way table has kind of like a column, or I guess this is a column here that just kind of is like, what are we talking about on this kind of this axis almost? And then I'm going to do something up here where we're going to talk about, and then I'm going to do. So we generally have the two variables that we're talking about. So we're talking about a survey was taken of 100 families. So what was the responses that we asked? So we asked them whether or not they had 2 or more children, right? So so basically family size. So that's what I'm going to call this. So I'm going to put family size on the top. And so I'm going to do 1 child or, greater than or equal to 2. I guess that's what we'll call it. So it says 100 families with 1 child and 86 families with 2 or more. And then the other part of this question, so not only did they kind of determine how big their family was, but the other part they were asking was whether or not they saved for college. And a lot of times that's going to be a yes or no kind of, I guess, response. So I'm going to put down savings as my act. So think of this as kind of like a graph, right? You kind of label your axes, similar way. So now what we're going to do is we're going to add in all of our values here. I'm going to add on one last column here. I forgot about this one. So we do need to have a total column, right, for my marginal frequencies. All right. So if I had 100 families with 1 child, so the way I have mine set up,
there's 100 families with one child. That means this total has to be 100. And then it says there's 86 families with 2 or more children. So again, family size, 2 or more. This has to be 86. So by giving me this information, I know a lot. I know that the total number of people, families surveyed, is 186. And then I can kind of start filling in the rest of the data once I use in the rest of these numbers. It says, of those, 94 of the families with one child, so again, we're looking only at the one child, 94 of the families with one child and 60 of the families with 2 or more were saving for college. So 94 said yes and 60 said yes here. So now what we have is we can kind of fill in the rest of the table. So we can add those together and get 154. We can add these together, or subtract actually, and figure out that that's 6. Figure out this is 26, and figure out that's 32. So this is how we kind of create a two-way table. And again, your two-way tables are kind of always done the same way. It's like a big rectangle and then another rectangle. Anyways, this is kind of how you organize your data given a situation. The next part of it says, find and interpret the marginal frequencies. So again, the marginal frequencies are all these kind of sum columns. So you could say something like 154 families saved for college. So that's one thing. You could have said 32 families don't save for college. You could say there were 100 families have one child. Another total would be, you could say 86 families have 2 or more. So all you're really doing here is just kind of putting into words. You're just putting into words what we have on our table. It says we can also, so 186 is kind of the big one. You could also say there are 186 families surveyed. So that's what it means by interpret the marginal, or I'm sorry, yeah, in marginal frequencies. All right, let's turn this over. Let's do a couple more. All right, so in a survey, 214 ninth graders played video games every day of the week, and 22 ninth graders did not play video games every day of the week. Of those that played every day of the week, 36 had trouble sleeping. Of those who did not play every day of the week, 7 had trouble sleeping. Make a two-way table with joint relative frequencies. Okay, so I'm gonna do 2 tables here. So it says make a two-way table that shows the joint and marginal relative frequencies. So I find it helpful to actually have the two-way table okay, so I'm going to draw my two-way table. Okay, so there's my two-way table. So I'm going to start by putting out my information into my two-way table. So think about what we were asked. It says 214 ninth graders played video games every day of the week. And 22 did not play video games. So they were asking about video games and not video games. So we would say, I could say something like, we'll just say video games. And we could say every day, what was the 2 categories? The every day of the week or not every day. So every day or not. I don't know, however you want to word it in terms of like how you gather your data. And the other thing with what they asked about was like trouble sleeping. So this is sleeping patterns. We'll just say sleeping. And we'll say, yes, they had trouble sleeping, or no, they didn't have trouble sleeping. So those are my 2 categories. So if I add in all my data into my categories, 214, it says 214 ninth graders played video games every day of the week. Of the week, and 22 ninth graders did not play video games every day of the week. So every day of the week, 214 played video games. So that means this total has to be 214. And not played video games has to be 22, which makes our total people surveyed 236. So the next piece of information I was given, of those that played every day of the week, so now we're just looking at this row, 36 had trouble sleeping. So yes, they had trouble sleeping. Of those who did not play, so that's this row, 7 had trouble sleeping. So that's that number. So now that we have kind of the data, we can fill in the blanks. So we can call this 43, we can call this 178, this would be 15, and this would be 193. So this is a two-way table, right? So now we need to make a two-way table that shows joint and marginal frequencies. So what I'm going to do is I'm going to make another table. Okay. Okay, so here's my other table. Now I'm just going to record the joint and marginal frequencies. So this is video games. I'm just going to put video, and I'm going to say my same thing. So I'm going to say every day, and I'm going to say not every day, so not. And then this was sleeping, and they had trouble sleeping, yes, and they didn't have trouble sleeping, no. And this was my total. So a joint frequency, we're going to grab our calculators here. We're going to do a joint frequency would be 36 out of 236. So I'm going to take 36, I'm going to divide by 236, and I get decimal. So we're going to do 3 decimal places, so 0.153. So when we calculate our joint and marginal frequencies, all we're doing now to get this value here, we're going to take 178 divided by 236. And if I do that, I get 0.754. I'm going to do the same thing over here for not. So 7 out of 236 is 0.030. And then 15 out of 236 would be 0.064. We can do our sums. So this one gave me 1.183. This gave me 0.818. This gave me a sum of 0.907 and 0.094. So what you should notice in a joint or marginal frequency, this total should add up pretty close to 1. Now, obviously, you might be a little bit off because of rounding, because we rounded to the nearest thousandth, but it's going to be really, really close to 1. So whether you add up this group of totals or this group of totals, you should get a pretty close total of 1. So that's what it means to make a two-way table. This is what it means to make a joint and marginal. So a two-way table that shows joint and marginal frequencies. All right, number 5. So this one says, for financial reasons, a school district is debating about eliminating a computer programming class at the high school. The district surveyed parents, students, and teachers. The results given as joint relative frequencies are shown in the two-way table. What is the probability that a randomly selected parent voted to eliminate the class? So what we're looking at here, so what they gave us is just kind of our raw data. They didn't give us any totals on this one. So if we wanted to, we could kind of calculate all the totals. But let's see what they want us to do. So what's the probability that a randomly selected parent, so we're looking at parents, voted to eliminate the class? So parents that have voted to eliminate the class would be 0.58. So we want the probability of a parent who voted yes, so it would be a parent and that they voted yes, over the probability that you're a parent. So it says, what is the probability that a randomly selected parent, so we're only looking at the parent column. So we're looking at that parent column and then we're comparing that to the 0.58. So the first thing I did was added this up to figure out my total. So the probability of yes in a parent was 0.58. And the probability of being of just a parent was the total of 0.64. So that means I know that my probability that a randomly selected parent voted to eliminate the class was this ratio, which is about 0.906, or if you wrote it as a percent, 90.6%. So the probability that a randomly selected parent voted to eliminate the class would be pretty high, about 90.6%. What is the probability that a randomly selected student did not want to eliminate the class? So now we're only talking about students. So now we're only talking about 0.23. So that's that total. So this is just our joint and relative frequencies, right?
So now we're going to do the probability that is no and a student. So no and a student is, whoops, 0.0 or 0.15 over the probability of being a student. So the probability of being a student is 0.23, which gives me 0.652, which is roughly 65.2%. So you can kind of see here that the students, randomly selected student did not eliminate the class, whereas the probability of randomly selected parents did want to eliminate the class. Next, it says determine whether the voting to eliminate the class and being a teacher are independent events. So how I kind of measure this one is, there any overlap? So determine whether voting to eliminate the class and being a teacher are independent events. So notice there's three kind of categories here. Does being a teacher and eliminating the class, so being a teacher and eliminating the class, does that have any overlap? And the answer is no, because you're going to ask teachers, right, whether or not they want to eliminate the class or not, and they're going to vote. But their response is not going to be kind of recorded in more than one spot. So we call that an independent event. So are they independent events? I would say yes. I would just say they do not depend on each other. All right. So I was going to go ahead and kind of walk through some of the extra example problems from our packet. If you would like to kind of do those with me, please stay on the video. If you feel like you have a pretty good grasp of this, you can go ahead and try it on your own if you'd like. But I'm going to go ahead and move to our extra notes packet, which is this 10.3. Okay, so it looks like this. It's in that extra notes packet that I had you guys print off. All right, so let's go ahead and get started. There are 16 juniors, 24 seniors on a debate team. Of these, 7 juniors and 19 seniors qualify for state debate competition. Organize this information in a two-way table, then find and interpret the marginal frequencies. Again, start by kind of drawing your table. All right, so there's my table. All right, so we're going to organize our data into a two-way table. So let's go ahead and talk about kind of the things that we're referring to. They're juniors and seniors. So I would say this is, I guess, what class you're in. So you could say junior and senior. I'm just going to abbreviate, and this is going to be my total. And the other thing we were asking for was whether or not they qualified for state debate. So I'm going to say qualified. The answer is yes or no. Did they qualify or did they not? All right, let's organize our data. 16 juniors and 24 seniors on the debate team. So 16 total juniors. So here's my juniors. I need to have a total of 16. And 24 seniors. So this needs to be 24. So what I know automatically is that there are 40 people in my survey. Okay, great. Of those, 7 juniors and 19 seniors qualified for state. So of the juniors, 7 qualified for state and 19 seniors qualified for state. So now with that information, I should be able to figure out the rest. So we can go ahead and take a second to fill in the rest of the missing numbers. And then we have a completed two-way table. To go ahead and interpret the marginal frequencies, again, you're going to talk about these columns, these sum columns. You could say there are 16 juniors surveyed. Actually, that was kind of already given to us, right? So maybe let's do some other information. Like, I guess the 16 juniors and the 24 seniors was already kind of given to us. But let's use this one then. So like 26 people surveyed. I would say 26 students qualified. So of our survey, 26 students qualified. And we could say 14 students did not qualify. Okay. And the other thing we can say is this total here. So we can kind of talk about those 4. We can say 40 students, and we'll just say 40 total students. So because we've already talked about those two in the beginning, like those were already kind of given to us, we didn't really have to restate them on this one. All right, next part says make a two-way table that shows the joint and marginal frequencies. All right, so same deal. So let's make a two-way table. All right, we're gonna do still a class, and this is junior, senior, and my total, and this is still gonna be qualified, and this is gonna be yes versus no. Move this down some so you can see. So now we're gonna do the joint relative frequencies. So all we're doing is, it says, show joint and marginal frequencies. So all we're really going to do is we're going to figure out these ratios. So we're going to look at our two-way table and we're going to say 7 divided by 40. So 7 divided by 40 gives me 0.175. So my joint frequency here is 7 divided by the total. So I got 0.175. And so then I want you to just kind of do the rest. So you can do 9 out of 40 and get 0.225. You can do 19 out of 40, again, those joint frequencies, and get 0.475, and then 5 out of 40 and get 0.125. Remember, the total should be at least close to 1, but again, rounding will cause a little bit of a difference. So if I do this, I'm going to get 0.4, and here I'm going to get 0.6. And then this one I'm going to get 0.65-ish. And this one I'm going to get 0.35. So this is my original two-way table with kind of raw data. This is my joint and relative frequencies. All right, make a two-way table that shows conditional relative frequencies. We haven't really done this one yet. So let's go ahead and do another one. Let me grab my other thing. And so again, kind of same deal. On this one, we don't really need a total. So I'm gonna make this one a little bit different. So on this one, I'm just gonna do, I guess we'll kind of do the names. So this is still our class. And so this is still juniors and seniors. And this is still qualified. And yes versus no. All right, so conditional relative frequencies would be to take like the frequency over the marginal frequency. So on this one, what I'm actually doing here is taking 0.175 to get this data, 0.175 divided by 0.4. So if I wanted to do that shows conditional relative frequency based on the row totals. So I asked for the row totals, not the column totals. So we can do conditional relative frequencies based off of, like if I wanted to do off of the people who qualified for state, or if I could do the conditional relative frequencies based off of your class, juniors versus seniors. So because I said row totals, I'm looking at it this way. So I'm going to do this number divided by this number. And so I get about 0.438. And then to get this number here, I would do 0.225 divided by 0.4. And I would get about 0.563. So those would be my conditional relative frequencies. And then I would do the same thing for the next row. So 0.475 divided by 0.6 gives me about 0.792. And then 0.125 divided by 0.6 gives me 0.208. So this is what we do for conditional relative frequencies. Notice that I didn't do anything with the totals, so I only really needed kind of this middle part of this table. So you didn't have to kind of draw the rest of it. All right, so that's a good example of kind of one of each. Let's go ahead and kind of answer some questions. I'm kind of tired of the table. Let's go ahead and see if we can just kind of answer some questions based off of tables that were already done. All right, so a store surveys customers of different ages. The survey asks whether they would like to see the store expand its toy department. The results given as a joint relative frequencies are shown in the two-way table. So again, we're talking about the age of somebody, and then whether or not they want to see the toy aisle expanded. So what is the probability that a randomly selected customer whose age is between 10 and 20, so here's a randomly selected customer between 10 and 20. So what I'm going to do is I'm going to go ahead and figure out this total. So I'm going to add those together. A randomly selected person who's between 10 and 20 would not like to see the toy department expanded. So I want the probability of, so the 10 and 20 years old, so 10 to 20, and no. So that's what I'm looking for. Probability of 10 to 20-year-olds and no. So this is 0.17 out of a total of probability of 10 to 20-year-olds compared to only the 10 and 20-year-olds. 10 to 20-year-olds. So you're only looking at this column right here. So of this column, what's that probability? Well, if you only surveyed the 10 to 20-year-olds and you asked if they wanted the toy column extended, and they said no. So it's 0.17. So you would get about, let's change that into a percent, about 73.9% here. Okay, let's look at this one. What is the probability that a randomly selected customer who would like to see the toy department expanded? So a customer that would like to see the toy department expanded is in this row right here. So this total, let's add up those numbers. I got 0.56. So of that total, so that's the kind of the total that I'm looking at. They have to be younger than 10. So the probability that they're younger than 10 is 0.27. So the probability that they're younger than 10 out of only the people who wanted the toy aisle expanded. But imagine this would be figure that would be kind of high, but it's only 48.2%. All right, determine whether replying yes and being younger than 10 are independent events. So the probability younger than 10 equals 0. So what we're saying is, are they independent events? So if you reply yes and you're younger than 10, could there be an overlap here? And the answer is yes. There is. Are they independent events? No, because there's an overlap here. Because if you replied yes, right? If you determine whether replying yes and being younger than 10 are independent events, because of the fact that you could be both younger than 10 and and reply yes, but also you could be older than 10 and reply yes, or older than 20 and reply yes. There is overlap in that case, so we would call this not independent. Let's look at number 3. So an airline company strives not to lose luggage for passengers. A manager at the company randomly selects 3 flights to check on lost luggage. At the end of each day, the manager determines whether or not their luggage was lost on that flight that day. The table shows the findings. Which flight does the best at not losing the luggage? So this is a different kind of table. Notice this is kind of using kind of tally marks. So the first thing I did on this one is I kind of figured out the totals here. So it said, I looked at, this was 10, so this was 10 people that lost luggage and 3 people that didn't. So that means there was a total of 13. So I was looking at total. So this is 9 plus 5. That means it's a total of 14 people. This is 12 plus 1, which is a total of 13 people. So the next thing I said, it says we want to look at which airline had the best probability of not losing your luggage. So let's look at the probability. So you could look at either one, but I looked at the lost luggage category. So basically what I did is I said, there were 10 lost bags out of 13. So that gave me 10 out of 13. For flight 2, I had 9 out of 14 bags were lost. So again, these are not great odds here. And then flight 3 had, looks like 12 out of 13 that were lost. So to figure out which flight does the best job at not, you want, obviously if you're looking at lost luggage, you want this to be the lowest, right? So I just changed these into percents. So 10 out of 13, I got 76.9%. 9 out of 14, I got 64.3%. And then flight 3, 12 out of 13, I got 92.3%.
away from that flight. So which flight does the best job of not losing your luggage? Well, it looks like 64.3% of the people surveyed got their luggage lost on flight 2, but that was the possible scenario. So I would say flight 2 was my best option. And so again, all you're really doing there is just kind of using the tally marks there to kind of gather your data and make a prediction. All right, that's it for right now. I know it's a long video, so I apologize. Go ahead and practice this, and then obviously come to class with any questions if you have any. All right, bye for now.